In this video, we are going to focus on sum and difference of cubes. So one of the most important things is just being able to recognize when you have a sum and difference of cubes. We use this to factor, and more specifically to find the zeros of a function. So let's say we have something like x cubed minus 27. And I ask you to factor this. So write factor next to that. Some of you might look at that and say, how in the heck do I factor that? I only have two terms. They don't have anything in common. What in the world do I do? If you come across a problem like this and that's what you're thinking, ask yourself, are those both perfect cubes? And if they are, then you can use a sum or a difference of cube formula. So let's first just refresh our memory. What are our perfect cubes? So we'll make a little table over here. That'll be our x value, and over here will be cubed. So if we have 0, well, 0 cubed is 0, because 0 times 0 times 0 is 0. If we have 1, 1 cubed is 1, because again, 1 times 1 times 1 is 1. If we have 2, 2 cubed is 8, because 2 times 2 times 2 is 8. Let's just go a couple more down. So 3 cubed is 27, because 3 times 3 times 3 is 27. And let's add 4 on there. 4 times 4 times 4 is 64. So this table can work both ways. You could say 0 cubed is 0, but you could also say that the cubed root of 0 is 0, or the cubed root of 1 is 1. The cubed root of 8 is 2. So you can go either way. Looking at these numbers here, do either of these match a number in our table? If so, that could clue us in that this is going to be a sum or difference of cubes. What I notice is that x cubed, that's obviously a perfect cube, right? X is cubed. 27, is that a perfect cube? Well, let's look at our table. Oh, 27 is 3 cubed. So we could rewrite that like that. So we have a perfect cube minus a perfect cube, which means we can use a difference of cubes formula to factor this. The difference of cubes formula, we derived that in class. You will not be asked to derive that again. Difference of cubes, you're going to start with a minus b, and this matches that sign. A squared plus ab plus b squared. These signs are opposite of this one. And this is how you factor a cubed minus b cubed. So if you recognize that you have an a cubed and a b cubed, then you can just plug it into this formula. Well, looky here. A is x, because x cubed is x cubed. B is 3, because 3 cubed is 27. So now we can just plug in our a's and our b's. And so we can say that x cubed minus 3 cubed equals x minus 3 times x squared plus ab would be 3x plus b squared would be 9. And there we have it. That's factored. That's awesome. Now, if you're unsure if you did it correctly, take your handy-dandy calculator, plug in your original, x cubed minus 27, plug in your factored form, x minus 3 times x squared plus 3x plus 9. And if you go into your table and these numbers are exactly the same, you know you haven't made a mistake, because your factored form should produce the same numbers as your original one, because factoring is just writing it in equivalent form. So there we go. We factored it. Now, if the question asks you to take it one step further and actually find the zeros, you are going to set each of these equal to 0 and solve. So let's just do an example of that. Find the zeros. Well, this one's easy. X minus 3 equals 0. X has to equal 3. Let's check. If I go up to x equals 3, oh wow, my function equals 0. So I know I did it correctly. Now we have to do the same thing here. We have to set this one equal to 0. So x squared plus 3x plus 9. Well, that's quadratic. How do I solve a quadratic? I have multiple tools in my toolbox. I could try factoring. I could try completing the square. I could even do the quadratic formula. Now, when I look at this, right off the bat, I don't see something that's going to factor. I don't know two numbers that multiply to 9 and add to 3. We have 3 and 3, that doesn't add to 3. And we have 1 and 9, that doesn't add to 3. So that clues me in that maybe I should try the quadratic formula. Remember, you have a really cool song to remember it. Negative b plus or minus the square root of b squared minus 4ac over 2a. So there we go. Now we just have to identify what is a, b, and c. A is 1 because our coefficient here is 1. B is 3. And c is 9. I'm going to plug these values in. So we have negative 3 plus or minus the square root. 3 squared is 9 minus 4 times 1 times 9 all over 2 times 1. Well, you always start by simplifying your discriminant first. 9 minus 4 times 1 times 9 would be 9 minus 36, and so we'd have negative 3 plus or minus the square root of negative 27 over 2. Ooh, there's a negative in here. I know that there are going to be no zeros from this. This is going to be imaginary. My final answer here is going to be imaginary, which means that there are no real zeros. So the only zero of this function is x equals 3. Let's check it out. Let's graph it and see if that's true. Well, that's not a very good graph. Let's try to zoom out. Oh, it's still thinking. I gotta wait a second. Okay, I'm gonna hit zoom, and I'm gonna zoom out. There we go. There's our graph. Now this is a cubic function that we started with, so we know the end behavior is going to go in opposite directions, and it's only going to cross one time, and it crosses at x equals 3. So we know that we did that one correctly. In this problem, we're going to factor x cubed plus 1. So you might look at this problem and think, where do I start? But remember, if you have two perfect cubes, you're going to use the sum or difference of cubes formula. So here, can I rewrite this as two perfect cubes? Well, we have x cubed plus 1 cubed. That tells me right off the bat that I can use either the sum or the difference of cubes. Because this is a plus sign, I'm going to use sum of cubes. So sum of cubes says that a cubed plus b cubed equals a plus b. These signs are the same. Times a squared minus ab plus b squared. This sign is opposite. This sign should always be a plus sign because any number squared is always plus. Now, all we have to do is plug in our a's and our b's. Well, when we rewrote it as cubes, we figured out our a and our b. So we have x cubed plus 1 cubed, meaning our a is x and our b is 1. So equals x plus 1 times x squared minus 1 times x is just x, plus 1 squared is 1. That is our factored form. So there's our factored form. Now if we're concerned that maybe we goofed up, we can always take our handy dandy calculator and we can plug in our two equations. So our original was x cubed plus 1, and our factored form was x plus 1 times x squared minus x plus 1. If I factored this correctly, when I go into my table or my graph, I should get exactly the same outputs. And I do. So I know I factored it correctly. Now, we factor things so that we can find the zeros. Well, this zero is really easy to see. What is the zero here? Oh, it's x equals negative 1. And again, we could go and we could check our calculator. And look at that. When x is negative 1, my function equals 0. So we know that that is one of our zeros. We could graph this. And when we do, we see that it only crosses in one place. So that is the zero of our function. You could take the time and do the quadratic formula, or you could complete the square. But what you're going to find is that the zeros here are imaginary. And so they're not real zeros. And therefore, you are done.